Question 14. So in this question we're trying to change words basically into the probability rules that we already know. So we're given in any given year the probability of getting a puncture in your car tire, so P puncture is one thing, and the probability of damaging a headlight is given. Given that they're independent events, what is the probability, correct to 2 decimal places, of having a puncture or damaging a headlight in a year? So basically we're given a probability of A and probability of B. We're told that they're independent, and then we're asked to find, well, find probability of A or B, so A union B. And if you're still not sure about the ands or ors, if you just have a look at a little Venn diagram. So if this is A, this is B. So A or B means anywhere in that entire area, which I'm going to paint with a bit of colour for fun. This whole area is A or B, and so that's the union of A or B, the union of A and B, that whole region that includes both of them. And A and B is that little area in there, which is also the intersect of A and B, which would be like that. But that's a slight aside. Hopefully you knew that already. Well, let's use this diagram for a second. So we're asked to find the union of A and B, so I might as well spell this out. If you have a look at what that area is, which is this whole area, we need the area of A plus the area of B, but that's going to give us that little overlap twice. So the entire sum just means we're going to get the whole area of A and B minus that little extra bit. So easy. So probability of A union B is equal to the probability of A plus the probability of B minus probability of A union B. Now, we're given that one and that one. All we need is that one, and we get that from independence. So if you're following along with your textbook, Miller and Freud's Probability and Statistics for Engineers, this is theorem 3.9, but hopefully you remember this already. Basically it is, if they're independent, then that means that that thing is equal to the probability of A times the probability of B. And when you did your basic probability and stat stuff right at the start, that's what you kind of use to follow those tree diagrams out. We are assuming independent events when we're talking about flipping coins and that sort of thing. So that makes this easy. So that means our final sum is just probability of A, which is, we'll call probability of puncture probability A, that's 0.16, plus the probability of the other one, 0.13, minus 0.16 times 0.13, and that's going to give you 0.27.